Okay, so bearings. So what's the application of bearings? What's the function of bearings by using any mechanical components? So basically, the bearing is applied to a rotating shaft, okay, and to reduce the friction. Okay, to reduce the friction. Usually, the bearing uh, whose inner ring is rotating and its outer ring is fixed, and this bearing is installed by a housing, okay, by a housing. Okay, and therefore how to evaluate its life under a load is the purpose that we have to learn for this section. Okay, so therefore we care about its reliability. Okay, and then we can evaluate its reliability from the catalog. Okay, the catalog provided by the bearing manufacturers. Okay, the bearing manufacturers. And the classification of the bearings has two types. Basically, have two types. The first is called the ball bearing. Okay, the ball bearing and the roller bearing. Well, obviously for the ball, well, it's the ball between the inner and the outer ring, and for the roller bearing, it's the cylindrical rod or a taper roller bearing between the inner and outer ring. Okay, and the separator is used to separate the balls and the inner and outer ring. Okay, and as I mentioned previously, this can be used for rotating shaft, right? Like the transmission. The transmission. Therefore, the diameter of the shaft, which has to be smaller than that of the inner ring of the shaft of the bearing. Okay. Okay. So what's this mean? I mean, if the shaft diameter is larger than the inner diameter of the bearing, what's that mean? That mean it's a press fit, right? That's mean a press fit. That's mean this shaft is not gonna be disassembled forever. So it's gonna be installed permanently. Okay. Okay, so this shows the ball bearings, right? Okay, so the inner ring is called the ball, and the separators right here is for separating this ball from the inner ring and outer ring. Okay, and it's called the shoulders. Okay, the shoulders. Okay, so you can just look at it. So it's have different name on it. Okay. Okay, so for the ball bearing, there basically have two types. There are many types of the bearings, but we can classify in the deep groove. That's the most common use. Okay, that's mean we have the groove for the ball installed. Okay, right? It's the groove, right? It's the groove. It's the groove. Okay, and the separator right here to separate the balls from the inner and outer ring. Okay, and the other type for this ball bearing is called the angular contact bearing. That's mean the ball is contact angularly, right? It's the inner and the outer ring. Okay, inner and outer ring. Okay, and also for this two ball, we say the trace of two balls. It's called the self-alignment bearing. Okay, that's mean when this shaft will kind of tilt a little bit, and it can automatically to align, right? It self-align this tilt shaft, okay, with these two ball trace, okay. Okay, so this shows the roller bearing, okay. So basically the divided into like the cylindrical and the thrust or the taper roller. bearing. Okay, so for this cylindrical roller bearing, which can be subjected to the radial force only, okay, and which cannot be subjected to the axial loading. However, for this, we say the thrust or the taper roller bearing, okay, so for this type of bearing, which can be subjected to the either the radial or the axial loading, okay, axial loading depends on what's the application that you are going to be utilized. Okay. Okay, so just some products for this roller and taper roller bearing. Okay, taper. I'm gonna introduce the taper roller bearing for detail for the next section. Okay, next section. Okay, so as we already learned some mechanical components, or we learn some stress analysis from the statics course or the materials mechanics course, right? We used to analyzing the stress distribution, right? However, for the bearing, which is not easy to analyze the stress. Okay, so for this, what we be trained in the mechanical engineer. Okay, so for example, we're gonna analyze, okay, so this ball, when it's rotating, right? When the shaft is rotating, this ball is subjecting to the radial force and the actual force, right? In two direction, and we have the resultants. We should have the resultants, right? And we can figure out what this resultant force is by stress analysis. Okay. However, it is not practical for bearing. Okay, therefore, this contact mode from the contact mode of the ball and the inner or the outer ring, the Hess mode doesn't work. And the forces push in many directions where it's rotating, right? When it's rotating, okay, so we can just consider the radial force. Okay, so maybe suddenly there's some vibration or there's some actual force applied. So it's quite complicated for the force, right? For loading. Okay, so that's why we say the forces pushes in many directions towards irregular geometry. Therefore, the theoretical conditions, well, not equal to the practical conditions because of many factors, like whether it's well lubricated, how is the sealing, and its installation, or maybe the ball or the roller is rusted, right? It's rusted, will increase the friction. Okay, therefore, for the bearing analysis, we are gonna use the traditional stress analysis. Okay, so we evaluate, we predict the bearing life. Okay, it's much more important than by using the stress analysis. Okay, so what's the bearing life? So we can evaluate the bearing life by the number of revolution to fatigue sign, or we can evaluate its bearing life by the hours at specific RPM to fatigue sign. We can say the fatigue, fatigue sign. So how to define a fatigue sign? So when we observe the bearings, the ball, trace, whatever, which has the pitting area is greater than 0.01 inch square, which is defined by the ABMA, American the Bearing Manufacturer Association. Okay, so when we observe the pitting area is greater than the 0.01 square, we define it. Okay, so the fatigue sign occur, and we define the bearing is going to fail. Okay. Okay, so the bearing life that I mentioned for the pitting area of the 0.01 and the life defines the number of revolution or the hours at the given speed. Okay, so for one bearing, we say the rating life required for 10% of the sample to fail. Okay, and for the group of bearing, it's called the minimum life, or L10. L10. So the L10 means the 90% of the sample have not shown failure at 10 to 6 cycles. Okay, 10 to 6 cycles. Okay, so there are some definitions. So here the catalog load rating C10, which is a constant radial load that causes 10% of the group of the bearings to fail at a bearing manufacturer's rating life. So the manufacturer will provide what's the C10 is for the bearing that you require. Okay, so it depends on type, geometry, accuracy, fabrication, and materials of the bearings. And it's also called the basic dynamic load rate or basic dynamic capacity. Okay, and the basic load rate C, which is a catalog load rating based on the rating life of 10 to 6 revolution of the inner ring, Okay, so the difference is that for the C10, which has the 10% of the failure, until we figure out there are 10% of the group of bearing to fail. And the C is we rating its life under 10 to 6 revolution of the inner ring. Okay, and the radial load or radial force, if R, that would be necessary to cause the failure at such a low life is unrealistically high. That means when this rotating is really, really slow and this radial load is extremely high. And in this situation, that may cause the failure of this bearing. Okay, and there's one important concept that we need to keep in mind, is that the basic load rating is a reference. It's a reference value, not an actual load, Okay, not the actual load. Okay, so let's think of how to evaluate its rating life. By experiment, of course, right? By how to evaluate the rating life can be the number of revolution, right? Until 90% of the sample, right, have not yet failed, or the minimum life, right? L10 or B10, or we always use L10. Okay, so by experiment, so we measure the force versus the life, depends on the cycles, and we plot the log-log graph, right? Log-log graph. So we can define the specific force, right? Until it's L10, there are 10% of the samples are fail, and we can, collect those data points. We can collect those data points, well, and then plug the log-log graph. It will transform to a linear function, okay, to a linear function. Okay, so and when we can define this linear function, right? This linear function is y equals to c, a constant divided by x, right? The power of n. And in this case, the y is the force, c is constant, L is the life. Okay, it's the life. And A here is defined by whatever the bearing you are using. For the ball bearing, the A equals to 3. For the roller bearing, either it's taper or cylindrical, the A equals to 10/3. Okay? And then we can rearrange this equation, right? We can rearrange the denominator right here. So we get a relation. We got this relation, right? And we usually use the 90% reliability to define the Kellogg load rating C10, which is equal to the load that causes a sign of fatigue for a specific number of cycles. Okay. Okay, so there's one examples here. Okay. So suppose I have a ball bearing, therefore we know the A equals to 3. And we desire this ball bearing has the life for 10 to 8 cycles, and which can be subjected to 400 pounds for 10 to 8 cycles. Okay, for 10 to 8 cycles. Okay, so we can plug this 2 into the previous relation that we already figured out, right? So it's will equal to this number. Okay, this number. Okay, so for here we define the D is desire. That means you require, you desire. What's this bearings whose life, and what's the force it can be, right, subjected to. R is rated. That means we evaluate or predict. And this rated life or load can be found from the catalog provided by the manufacturer catalog. Okay. So we can make it's equal. Okay, make this equation. So for the D, that's desire, that you want, what you want, right? What you want. So for here, what you want this bearing, which can last for 10 to 8 cycles under the force 400 pounds, right? So we can plug this number, sorry, here and here, right? And we got this number, right? Okay. And then we usually define the FR is C10, right? C10. And the LR is 10 to 6. Okay. Therefore, we can figure out what is a C10 is, right? What's the C10? C10 equals to 1,857 pounds. Therefore, if these two, load and life, is what we desire, and we can check the catalog from the manufacturer whether it's C10 is greater than this number. Okay? Okay. And there's a conversion between the hours to cycle or the cycle to hour. Okay? Okay, so it has this relation. You can convert it from cycle to hour, hour to cycle. Okay, so this represents the life at how many hours at the specific speed and times 60 minutes per hour. Okay. Okay, so there's the other examples. So we have two bearing A and B, right? And B, and this is the driving shaft, or say the driving gears. Okay, doesn't matter. So what we desire the bearing life is 8,000 hours at 1,600 RPM. Okay, and then we can convert the hours to cycles. So this is the desired life in cycles, right? Okay, so we also desire the load for bearing A is 200 pounds, and the load for bearing B is 300 pounds. And both of the bearing A and B have the desired rating life is 7.68 times 10 to 8 cycles. Okay, so let's go back to this relation, right? So our purpose is to figure out what is a C10 is that can be found in any catalog, right, of the bearing manufacturers, right? So in this case, okay, so it's the roller bearing. Suppose it's a roller bearing. Okay. So we can find what it's C10, what is this C10 is. Okay, so for the bearing A, we know the desired force and the desired life, right? And the LR 10 to 6, right? And then we figure out for the if for the users, I can select the bearing A from the catalog, right? If the C10 is greater than 6.53 kilonewton, well, it's okay. And for the bearing B, whose desired force is 300 and the desired rating life, right? And we calculate its C10. It's 9.8 kilonewton. So we can select the bearing A and the B from the catalog based on these two numbers. Okay, based on these two numbers. Okay, so this is recap what we learned here. So we can figure out the linear function, okay, by experimentally to plot this log scale. Okay, so and we can define the FL part of the 1 over A equals to a constant, right? Equals to a constant. Okay, and then we can define for this two load life condition. Okay, and one is for this rating life. Okay, for this rating life, that's mean defined by the manufacturer. And the desired life and force, that is what you want. Okay, that is what you want. Okay, and then we can convert it. We can convert it the life from the time to cycle. We can convert it the life from time to cycle. Okay, and then we can solve C10, which is the FR. Okay, which is the FR. Okay, which is the FR. And then we check the catalog provided by the manufacturers, what is the C10 is. Okay, what is the C10 is. Okay, so this is the relation for C10, which is the FR equals to FD times LD over R part of the 1 over A, right? So we can find a C10 by using this relation. Okay, there's the relation. So the desired design load FD and the life LD come from the problem statement. That means what you want come from the user. Okay, and the rate life LR will be stated by the specific bearing manufacturer, and many catalog rate at LR equals to 10 to 6 revolution. And the catalog load rating C10 is used to find a suitable bearing in catalog. Okay, in catalog. Okay, so as I want to mention, we are not gonna analyze any force or any stresses on bearings. We only estimate. We only estimate what its C10 is. Okay, what is this? Its C10 is. Okay, and we use the C10 to find what's the suitable bearing that we want from the catalog. Okay, from the catalog. Okay, and then we're going to define, it's called the dimensionless molten rating life. That's mean, in the previous slide, we defined the LD, that's the desired life, LR is the rating life, right? Either it can be hours or cycles, revolution cycles. Okay, and then we can make this rating life is a dimensionless parameter, the XD. Okay, so I'm gonna introduce how to use this XD later. So we are gonna widely use SD to evaluate the reliability of the bearing by using the Weibel distribution. Okay, by using the Weibel distribution. Okay, so I'm gonna stop this course here. Okay, so for the next course, I'm gonna introduce how to use the Weibull distribution to predict or to evaluate the reliability, okay, of the bearings. Okay. Okay, so if you have any questions, just email. Okay.